Hi, my name is Patrick Reagan. Welcome to Windows Tools Part 6, Resource Monitor and Performance Monitor. During this video, we continue our discussion on using Windows Tools to look at the performance of Windows using Resource Monitor and Performance Monitor. As always, stick around for the practice questions at the end, test your knowledge, and help you prepare for the A+ exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Has Your Back channel for more tech training content and technical know-how. Performance is the overall effectiveness of how data moves through the system. It's important to select the proper hardware, processor, memory, disk system, and network to satisfy the expected performance goals. Without the proper hardware, bottlenecks limit the effectiveness of software. When a component limits overall performance, that component is known as a bottleneck. When you relieve one bottleneck, another bottleneck may be triggered. For example, by increasing the memory, you can often increase the overall performance of a system up to a point. However, when you add more RAM, the RAM needs to be fed more data from the disk. Therefore, the disk becomes the bottleneck. So although the system may become faster, if your performance is still lacking, you will have to look for new bottlenecks. Often, you cannot identify performance problems by just taking a quick look at performance. Instead, you need a baseline to see what is normal for your computer when it is running well and within design specifications. Then, when a problem occurs, compare the current performance with your baseline to see what is different. Because performance can also change gradually over time, it is highly recommended that you baseline your computer as early as possible and regularly thereafter so that you can chart your performance measurements and identify trends. This will give you an idea about when a computer needs to be upgraded or replaced or the workload of the computer reduced. Resource Monitor is a powerful tool for understanding how your system resources are used by processes and services. In addition to monitoring resource usage in real time, Resource Monitor can help you analyze unresponsive processes, identify which applications are using files, and control processes and services. To start Resource Monitor from Task Manager, you can open the Resource Monitor by clicking the ... button and clicking Resource Monitor. You can also search for Resource Monitor from the Start page, or you can use the command prompt or Windows PowerShell to execute the resmon.exe command. Resource Monitor includes 5 tabs: Overview, CPU, Memory, Disk, and Network. The Overview tab displays basic system resource usage information. The other tabs display information about each specific resource. Each tab in Resource Monitor includes multiple tables that display detailed information about the resource featured on that respective tab. If you click the column header, you can sort by that column. If you select a process or service checkbox, the selected process or service is moved to the top of the column in Tables, and other tabs will filter on those processes or service. The CPU and memory shows you similar information shown in the Task Manager. Besides showing the overall disk performance of disk, including the queue length, you can also break down the disk activity by showing what files are being accessed and which files are consuming the most disk utilization. The Network tab allows you to monitor active connections, which will show you exactly which processes or executables are connected to the internet or local network, including remote IP addresses and port numbers. Track bandwidth usage by applications to identify which programs are consuming the most data, which is useful for detecting hidden downloads or malware. You can terminate connections by right-clicking a process if it is causing the network congestion or behaving suspiciously. Listening ports show you what program is controlling the listening port on the computer. Performance Monitor is an MMC snap-in that provides tools for analyzing system performance. It provides a visual display of built-in Windows performance counters, either in real time or as a way to review historical data. It is included in the Computer Management Console and can be opened as a standalone console from Administrative Tools. It can also be started by executing the perfmon command. From a single console, you can monitor application and hardware performance in real time, specify which data you want to collect in logs, define thresholds for alerts and automatic actions, generate reports, and view past performance data in a variety of ways. Performance Monitor has hundreds of counters available, much more than you can get from Task Manager or Resource Monitor. When you install Microsoft applications such as SQL Server or Exchange, additional counters will be available for a specific application. To add counters, you can right-click the main pane and click Add Counters. To change the graph type, click the Change Graph Type button. Performance Monitor can save the counters as a data collector set, or DSC, which can be pulled up at a later time and even scheduled to automatically execute when a trigger event that you define occurs. If CPU utilization consistently exceeds 80 to 85%, you likely have a CPU bottleneck. Percent processor time is the primary indicator of total CPU usage. Processor queue length measures threads waiting for CPU time. A sustained value above 2 per processor often indicates a bottleneck. With percent privilege time, high values here suggest the OS kernel or drivers are consuming resources, often due to hardware or driver issues. Context switches per second with excessive switching over 5,000 to 10,000 per processor can indicate software inefficiency. To diagnose memory performance issues in Windows Performance Monitor, focus on key metrics indicating low physical memory, paging activity, and application-specific leaks. For monitoring, memory/available megabytes should ideally be greater than 10% free. Memory/pages per second, high values indicate paging. To catch a memory leak, monitor these over several hours while the system is under typical use. Available megabytes is if this value steadily declines while your workload remains constant, a leak is likely. Committed bytes measures the total amount of virtual memory in use. A steady upward trend indicates a leak. Pull non-page bytes, specifically used to find kernel mode leaks. If this rises and stays high, the driver is likely failing to release memory. And process private bytes. Use this to identify which specific application is growing in size over time. For disk performance, focus on latency, which is time to complete a request rather than just throughput. Average disk sec per read and average disk sec per write. This is the gold standard for disk health. Less than 10 milliseconds is excellent, 10 to 20 milliseconds is acceptable, and greater than 25 milliseconds is a serious performance lag. Current disk queue length is the number of outstanding requests. If this is consistently higher than 2 per disk, the drive is struggling to keep up. Percent idle time, if this drops towards 0%, the disk is fully saturated. For networking, use the following counters to find drop data or hardware errors. Package receive errors indicates corrupted data or driver issues. Package received discarded suggests the system buffer is full and cannot process data fast enough. Output queue length, if this is greater than 0, there's a delay in sending packets out to the network. Question: you have a computer that is running slow. which two tools can you use to help you identify the issue? Choose two answers. Answers: Resource Monitor and Task Manager. Question: If the computer's running slow and you're suspecting high disk I/O, which program can you use to verify the problem? Answer: resmon.exe. Question: Which of the following tools allows you to view the use of hardware and software resources of a particular system in real time? Answer: Resource Monitor. Question: Which program allows you to view various performance counters in Windows? Answer: Performance Monitor. Question: An application's performance is degraded over time. The application is slowing, but it never gives an error and it does not crash. Which of the following tools should a technician use to start troubleshooting? Answer: Resource Monitor. Question: A suite of security applications was installed a few days ago on a user's home computer. The user reports that the computer has been running slowly since the installation. The user notices the hard drive activity light is constantly solid. Which of the following should be checked first? Answer: Performance Monitor to check for resource utilization. Question: A systems administrator is monitoring an unusual amount of network traffic from a kiosk machine and needs to investigate to determine the source of the traffic. Which of the following tools can the administrator use to view which processes on the kiosk machine are connected to the internet? Answer: Resource Monitor. For more information, refer to these sites. In summary, performance is the overall effectiveness of how data moves through the system. When a component limits overall performance, that component is known as a bottleneck. You usually cannot identify performance problems just by taking a quick look at performance. Instead, you need a baseline. Resource Monitor is a powerful tool for understanding how your system resources are used by processes and services. Performance Monitor is an MMC snap-in that provides tools for analyzing system performance by providing a visual display of built-in Windows performance counters, either in real time or as a way to review historical data. Thank you for watching this video. The next video will be Windows Tools Part 7, Computer Management and Microsoft Management Console. If you like this video, click the like button, and if you have not already, subscribe to the Pat Has Your Back channel. Thank you.